Greetings, Physics 112 students. I'm making this video here to help you out with 16, 17, 18 and Unit 2-1. Okay, so let's see. 16 says that a 8.5 volt battery is connected to the plate of a capacitor and it stores a charge. So I'm going to start with a quick little picture. I'm just going to do this here. We've got a capacitor here. It's hooked to a battery. So let's put a voltage symbol in for our picture. Now, with this polarity here, that means the capacitor would be charged like so. It has a certain charge on it. The voltage across the capacitor, by the way, is the same as the voltage of the battery, and the reason is because, remember, this is an equipotential. This is all conducting material to there. Same thing on the other side. And capacitance, here's how it's defined. It's defined as charge over voltage. So that's enough to answer that question right there. Part B, if the same capacitor is connected to a 15 volt battery, how much charge is stored? So in part B, this voltage is now going to change. I'll put a delta V2 here. But it's the same capacitor, so this will stay the same. This is a bigger value. You're going to get a new capacitance value. That's enough for that one. That's a pretty short problem. Okay, let's chat about 17. Let's see, an air-filled parallel plate capacitor has a given area and a distance separation of 1.6 millimeters. So when you're dealing with capacitors, here's my quick sketch of a capacitor, super quick. The capacitance, remember, is directly proportional, to the area, falls off with distance. And I think the proportionality constant is this, epsilon sub L, where this is equal to 1 over 4 pi k. And what you got to do is make sure that your units are all correct. Let's see. Yeah, so this you're going to know. Given in the problem, given in the problem. That should allow you to calculate this. Again, be very, they have to have consistent units. I'm noticing that they gave the area in square centimeters and the plate separation in millimeters. They have to be the same. In fact, I believe you want them both in meters. For part B, what is the charge on the capacitor? So remember, capacitance is equal to charge over voltage. This is given, and this is what you got in part A. That will allow you to calculate this. Part C, what is the field strength between the plates? Okay, so if I draw more of a side view here, with our capacitor charged, one side positively charged, one side negatively charged, then we're going to get electric fields between them. And potential difference between the plates, remember, is field strength times distance. So you're looking for this. This was given in the problem. And I think this is the second voltage I mentioned. So that should get you through 17. Okay, oops, I did not want to clear that whole deal, sorry. Okay, 18, let's see, air breaks down and conducts charge as a spark if the electric field exceeds 3 million volts per meter. So we've been given this, a field strength of 3 times 10 to the 6 volts per meter, and again that's dimensionally the same as a Newton per Coulomb. Determine the maximum charge that can be filled in a capacitor with a certain area. Determine the maximum charge that can be stored on an air-filled capacitor plate. Well, let's start with this. capacitance is charge over voltage. Now, in a parallel plate capacitor, by the way, let's see, here's my side view of my capacitor charged. This one I think is going to take a little bit of monkeying around here because we don't have a voltage here. But the voltage, the potential difference here, from here to here is field strength times distance. So I think if you take this and you plug it here, and capacitance we can say is epsilon sub area over D. I think if you take this and plug it here, you can get something to divide out, and you'll be left with only what you want to find. I'm pretty sure that'll get that problem done. Yeah, that'll find you the charge. Okay, well, that should, I guess that was 18. That should be enough to get those rolling. I'm going to call this video done here and work on another one.